Hi, this is another ESP32 project with Wi-Fi control. Now this ESP32 module, I have hooked it up on a PCB. These are all 2.2 kilo ohm resistor, which I have put it on each pin so as to protect them from, for example, a 5-volt input from like an arduino-uno. So these 4 LEDs I have hooked it up to pin 4, 25, 26 and 27, and this white wire is for the ground. This app you can download it from Play Store. This is a Serial Wifi Terminal app. Now let's just try and control the LEDs with Wi-Fi. Let's just connect it first through the Wi-Fi. Yeah, it's connected, and then sending the request to select pin 4 hash B7 4 hash. Yeah, pin 4 is selected. Now let's just blink it hash C00 hash. Now these are all just requests which is coded in the program itself. Program will be shared in my GitHub page, and let's just try to do the same with pin number 25, this LED hash B725 hash. Now pin 25 is selected and hash C10 hash. Yeah, oh my god, so basically they are in full synchronization. Good one. So let's just try to put an analog signal on the next pin, or pin number 26, which is this one. So let's just select pin 26 hash B726 hash, and then selecting the complex signal or the analog signal on pin hash C25 hash. Now the complex signal is enabled on this LED. As you can see, it's blinking and it's fading out, fading in, fading out. Now let's just try to blink pin 27 also, hash B727 hash C30 hash. Now this LED is also blinking. Now I want to change the blink rate of this LED, which is connected on pin number 25. So we have request for that as well. Now for the request is hash C5. So let's just try it out. Hash C5. Now let's just make it to 100 milliseconds. 100 hash. So it's blinking at a rate of 100 milliseconds. Now this LED is connected to pin number 27. This I want to make it to, let's say 400 milliseconds, or no, or maybe 50 milliseconds. Let's just go down. So for this we have request hash C7 hash C750 hash. So this LED is blinking at a very fast rate. So, and all these are being happening simultaneously because ESP32 we are using an RTOS version on it. This LED is blinking at 500 milliseconds. So let's just change this to 1 second or 1000 milliseconds. Let's just do it. Hash C4 1000 hash. So now as you can see, this LED connected on pin 4 is blinking at a rate of 1000 milliseconds. Now we can also, I have also request of runtime on this device. Let's just measure the runtime. Hash B2. So the runtime, as you can see, is 20 microseconds. It's a pretty fast processor here. And if you're guessing why it's 20 microseconds when it's using Wi-Fi, so I will tell you that Wi-Fi is running on core 0, and all this functionality, the blinking, is running on core 1. So the code is made that way that the task for Wi-Fi is running on core 0. All this print functionality also is running on core 0, but all this LED blinking functionality is running on core 1. Again, let's just try to print the hash B2. 20 microsecond hash B2, 21 hash B2, 22 hash B2. Yeah, so it's just goes around 21 and 22, and this 21 22 is also coming due to the fact that the read command from the Wi-Fi are running on core 1, so this is a little bit higher as expected. Now let's just try and do some other stuff. For example, I want to blink this LED as well, the LED connected to pin 2, which is on the board. The request for this is hash f. We have to select it first, so hash b72 hash, pin 2 is selected. Now we have to do service of this pin, the blinking. So the request for this is, yeah, hash f2 hash f 20 hash. Yeah, so the default blinking rate is 500 milliseconds. As you can see, it's blinking at the rate of 500 milliseconds. You can change this blinking rate also to around let's say 200 milliseconds. So let's do that. Hash f3 200 hash. So now as you can see, the blink rate has changed to 200 milliseconds as it's reflected here. So all these things are happening at the same time simultaneously because it's RTOS. Let's just try to print the runtime now. Hash b2. Runtime is still 20 microseconds. It's a pretty speedy processor. Now let's just do some more stuff. We can do like hard reset it using software. So let's just try it out, or we can go to an idle mode in which all these LEDs will stop blinking immediately. Request for that is hash b6. Let's just do that, hash b6. So now as you can see, this is in idle mode and all these LEDs have stopped to blink, including the GPIO pin 2. Let's just go back to normal mode, hash b6. Yep, they have started to blink again with the same rate. We can also set this complex rate as well. So for example, this is a little slow for me, so I will make it to around 2 milliseconds. Let's just make it to 2 milliseconds then. The request for that is hash e4. So let's just do this, hash e4 2 hash. So as you can see, complex period has become 2 milliseconds, and if you were noticing before, this has now become faster. The blinking has now become faster for this LED, the complex one, analog. Let's just make it to 20. So hash e4 20 hash. So see, now it has become very slow. It is very slow. Yeah, it's not exactly 20, like the rate is 20, not the time is 20. So yeah, now we can do again, we can hard reset it also, not the power on reset but the software reset using this one. Let's just do it out. But before that, I wanted to show you the lock feature as well. So basically all this request I'm sending through Wi-Fi, I can also lock this entire keypad, so any request I send will not be accepted until and unless I unlock it. So for locking it, the request is hash c. Sorry about this state. Yeah, hash b9 hash b9. Now as you can see, the Wi-Fi, this panel has now been locked. Any request I send after that, like for example runtime hash b2, it says MC is locked. Now in order to unlock it, we have to give a unlock key. So let's just try it out with the same request, hash b9 1 2 3 4 hash. Oh, it says key is invalid. Oh my god, the key is not good, key is not valid. Let's just make it a valid key, send a valid key. So the key is 1236. So let's just try it out, hash B9 1 2 3 6, then hash. So it says now it's unlocked. I can send the request. Let's just try it out. Runtime hash B2. You can see runtime is 20. Now let's just go into idle mode and then see the runtime. Hash B6. I hope it's less this time. Maybe. Let's see. Hash B2. Still 20. It's not affected that much. But these LEDs now, as you can see, are all stopped because it's in idle mode. Now let's go back to normal mode. Hash B6 normal mode. And for resetting, the request is hash C8. Hash C8. So now this has soft resetted actually. So all this procedure I have to repeat it again because this was all stored in RAM. I have not stored it in EEPROM, so all this will stop and it has been completely gone. Thanks for now. All this for this today's video. Thank you. See you later. Bye.